All right, fabulous team micro. In this lecture, the last lecture for the elasticity section, I think, I just want to talk a little bit about using equations rather than a demand schedule to describe demand and or supply. If I were to give you a supply equation, that would replace a supply schedule, for example. So this goes back to your algebra that you had either in 7th, 8th grade, 9th grade, whatever. There is a math prereq to this class, and so hopefully you all have satisfied that prior to getting into this class. You've just had some basic algebra and basic graphing. I know that at least for Cheney Public Schools, this is covered in 7th grade math. I've got a 6th grader who's taking advanced math, which is the 7th grade math curriculum. So I absolutely know this is exactly what he's covering. So this is exactly what he's doing. So that being said, it's 7th grade math. If you are a college sophomore, it may have been a couple years or 2 or 3 since you've had your 7th grade math. So it's worth brushing up on. But just know that I'm an economics faculty. I am not here to teach everything there is to know about graphing or math, that if you are struggling with the math, it is your responsibility to go to the math tutors, perhaps, if you find that it's really a problem. If it's a small problem, just a little tweak or something like that, I absolutely can help you. I know math inside and out, but I'm not going to tutor on algebra, okay? So if your algebra is way rusty, you may have to go see a math tutor. If it's just a quick question, absolutely shoot me it. Okay, I can answer quick questions, but I'm not going to give full lectures on how to do algebra. That's the math department's job. I would never want to take a job away from a math professor. And so I stay in my own lane, which is economics, and just assume that those math professors and those math teachers did a fantastic job of preparing you with the math tools that you're going to need in my basic math or my basic economics class. So that being said, hang on, here comes some math at you, okay? So now we're mixing it up. Instead of giving you a bunch of P's and a bunch of Q's and then just saying, go plot it, right, which you've been doing, now we're going to give you an equation and say the same thing. Go plot it. Okay, so what I have created is a handout. And again, because you're following along with all of my personal lectures, by now you guys are tired of this, you know the drill. You go, you open the handout, you open up the lecture, and you do the handout while you're watching the lecture, right? So same thing, I'm going to open up the handout that accompanies this lecture. And I believe I'm going to share my screen real quickly. If I can find it. That handout is called Using Equations to Describe Demand. And I put or supply, even though I don't address supply in this handout, it'd be the same thing if I gave you an equation with QS and a function of P. You would do the same thing and you would plot out a supply curve, okay? All right, so hang on. So here is, I have typed up in words for you, in addition to what I'm going to say at you verbally here, how to proceed when you're given an equation, hint, hint, like you're given on the homework, right? Oh my gosh, I haven't seen an equation. You freeze for a moment and you go, I don't know what to do. And then you breathe and you say, okay, hold on. I had this amazing 7th grade math teacher, Mrs. Jones. Thank you, Mrs. Jones, for giving me the tools that I needed. And hopefully I was paying attention in Mrs. Jones's class and I wasn't flirting with some other student, right? Or checking my phone and ignoring the very, very important stuff that Mrs. Jones was telling you in 7th grade that you now need in your 2nd year of college, right? Don't you wish you would have paid more attention in 7th grade? Just kidding. All right, so here we go. So in addition to using, I'm just going to read. I know I hate when professors read because you guys perfectly are literate and can read, right? But in addition to using demand schedules, we often will use these equations. Okay, so here we go. And again, I know it's 7th grade math. I already told you that, right? So I'm going to come over here and I'm going to say, let's say that we're given a demand curve of the form QD equals 500 minus 50p. Since we already know this is a straight line, hey, Kelly, how do we know it's a straight line? Well, we have two variables, a P and a Q, and both of them are in level form. What that means is they're both raised to the first power. It's not like P squared, it's not like P cubed or Q cubed, anything. There are no exponents on those P's or Q's. This is gonna plot as a straight line, okay? All right, two variables, both at the first level, straight line. Just a refresher. Okay, So since we know, ta-da, I'm an expert in linear equations now. This is a straight line. What we need to do is find the intercepts. Where does it cross my X and my Y axis? Now you've seen enough demand curves to know this is a downward sloping curve. Let me go this way. It's a downward sloping curve from P to Q, and it might in fact intersect with both the P on the vertical axis and the Q on the horizontal axis. Okay, if I can find 2 points, any 2 points, and you connect them, that will make a straight line. It's one of those theorems, those laws in mathematics. Any 2 points makes a straight line. You can draw a straight line between any 2 points, right? Ta-da! I remember my fantastic 7th grade math teacher. Thank you. Anyways, so one way that we can do this, one way obviously is you can rewrite the equation y equals mx plus b, and then just pick off your y-intercept, and then so on. You have your slope on there, everything's fine. That was one way that you learned. That is not incorrect. That's a little clunky. It's going to take a few more steps. The reason being that we economists, I hate saying this, but we have violated the conventional laws of mathematics in the sense that even though in this equation that I have given you, Q equals 500 minus 50p, it looks like the Q should be on the y-axis. You know from the supply and demand lesson that that is absolutely wrong, that the P always goes on the vertical axis. So with this equation, P would actually be your y variable, and Q is what's on your x-axis. So Q is your x. So in order to get this equation as it is written, QD equals 500 minus 50p, into y equals mx plus b form, you would first have to invert it. And you would have to solve for p. Now you could do that, absolutely. I don't want to discourage you. Go ahead and do it. It's not wrong. It's just going to take some extra steps that I don't think you need to do. Okay, so what you really want is not necessarily, I didn't ask for, hey, what is the y equals mx plus b form? You could do that and show off. That's fantastic, right? Wonderful. But we want to just get to the intercepts. What is the quickest, most efficient way? All about efficiency in economics. What's the most efficient way of me taking this equation as given and plotting my 2 intercepts and drawing a line? Bam, I have my demand curve, right? Piece of cake. What we remember is that when the line, let me go this way. I keep going the wrong way. It's inverted from, because you guys are watching me in a different direction. When we're going down that demand curve, that when it crosses the axes, the value for that axis, the other value is 0, right? So in order to find the x-intercept, for example, okay, to find the x-intercept along that horizontal x-axis, we have to set the y variable to 0, and vice versa. To find the y-intercept, you set the x variable to 0. So what this means is we want to do 2 things. We want to set p equal to 0, solve for q. We want to set q equals 0, solve for p. So when we set p equals 0, we're asking what is the most that we could give away if we were giving this away for free. And on the other hand, when we set Q equal to 0, we're asking, what is the choke price? What is that price, that maximum price beyond which nobody would buy my item, where it chokes off demand entirely? Okay, so when Q equals 0, what is that price on the vertical axis? Okay, so let's look at that. An easy way to find the vertical and horizontal intercepts is to alternately set P equals 0, solve for Q, then set Q equals 0 and solve for P. So using this equation, now that we know this quick and dirty trick to get to my intercepts and then just connect them and draw the line, right? Let's do step 1. Let's set P equal to 0 and solve for Q. So when P equals 0, we plug that into the equation. QD equals 500 minus 50 times 0, and that's going to equal 500. Because I know that 50 times 0 is 0, 500 minus 0 is 500. So we know that the horizontal intercept is going to be at the point where P equals 0, QD equals 500. And that's the point along the demand curve on the horizontal axis. That's the maximum that I would ever give away in this case, okay? Now to find the vertical intercept, I'm going to set Q equal to 0 into the same original equation. QD equals 500 minus 50p. So notice when I substitute the 0 for the QD, I get 0 equals 500 minus 50p. Therefore, adding 50p to both sides, whatever your algebra, however you were taught this by your fantastic middle school math teachers, right? You're going to add 50p to both sides. You're going to get 50p equals 500. Then you're going to divide both sides by 50 to get p all by itself. And when you do that, you're going to get p equals 10. So we know that when Q equals 0, P equals 10, and $10 is the choke price. That's the maximum price that someone is going to be willing to pay. Okay? All right, so now let's take those 2 points. 1 point, P equals 0, Q equals 500. Another point, P equals 10, Q equals 0. And we're going to plot those. Ta-da! And it looks like this. Let me shrink this so it fits on the screen. Ooh, just a little better. And there you go. Right? It's still cutting off. Okay, a little bit of OCD here. Let me fix that. There we go. And so you can see that when the price is $10, my quantity is 0. And when my quantity is 500, my price is 0. Have my 2 intercepts, draw a straight line. You can tell I did that freehand, but it came out pretty decent. You can tell that's supposed to be a straight line. That's my demand curve. And there we go. So now we have sketched the demand curve. All right. Now the cool thing is using this equation, and I have it written right here in freehand, QD equals 500 minus 50p. If we know any price, we can plug it in and we can find out the quantity that we would expect to sell. So let's say you're thinking about 750. So your boss comes into your office and says, how many units do you expect we would sell at a price of 750? You go, oh, hold on. I know that. Here you go, boss. And in 2 seconds, you give them the answer. You sound like a genius and you get a promotion. And you tell them that you're from Eastern Washington University, where they have fantastic economics professors that trained you, right? Cool. Paves the way for the next round of students coming through behind you, right? Go EWU. All right. Anyways, so you could take any price. You could take $5, you could take $9.75, you could take $4.50, whatever price you want. Plug it into the formula and you could predict what quantity. On the other hand, if your boss comes into your office, knock, 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 hey, fabulous econ student, I know you have this fantastic degree from Eastern Washington University, so I want to know, I have 630 units and I want to sell 630 hamburgers. In order to sell that, what price should I charge? Hold on. And you put in 630 for the quantity, ding, 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 so and solve for P. And you say, okay, boss, in order to sell 630 hamburgers, here's the price you would need to charge. Boom. And your boss calls down to the hut that sells the hamburgers and said, change your prices to this because Bob is an excellent student and knows, or excellent worker and knows what they're talking about because their degree's from Eastern Washington and that's the best in the state, right? Cool. Okay. Anyways. So if you know P, you can find Q. If you know Q, you can find P. That's the handy dandy neatness of one equation. How cool is that? You don't need a table. You don't need to go, hold on, let me pull up my spreadsheet. Oh, it's not on my spreadsheet. What do I do now? Right? No, you've got the equation. You just plug it in. Piece of cake. You guys are awesome. All right. Way to look smart. Way to look smarter than those UW and WSU people. Okay. Anyways. They're teaching them the same things too, because I actually got my degree at WSU and I used to teach down there. So I know I was teaching the same stuff to them. You're getting the same education that the UW peeps and the WSU people are getting. So you should feel pretty good because you're paying cheaper for them. All right. Anyways, little secret. So here we go. Since we already know that when Q equals 0, P equals 10, we want to know what would P look like for different intervals of Q. So for example, the boss says, how about 100? How about 200? How about 300? How about 400? And the boss said, hey, can we sell 600 hamburgers? And you go, oh, heck no, because nobody would pay. Nobody even wants them. And the most we could ever give away is 500. So you tell the boss, sorry, there's not that many people coming through our gates that want hamburgers. Okay. Anyways, So whatever the different interval is, if QD equals 100, we put that into our equation and we would see what the corresponding price would be. So you can see down here on my handout, when QD equals 100, you plug in for QDs. Notice how I substituted from the QD up here to now it's equal 100 equals 500 minus 50p. Only one variable, p, I can solve. Add 50p to both sides, subtract 100 from both sides, and p would equal 8. I know I did that quickly. Again, I skipped steps, assuming that you remember your algebra. You may need to take a couple intermediate steps to get that, just to remind yourself what are the rules of algebra and to brush up on your 7th grade algebra. But you got this. I know you do, because I know that you were glued with anticipation and attention to what your 7th grade math teacher was teaching you. Because when she said, you're going to need this later, you understood and knew that you really would. Okay. All right. So now at p equals 8, QD equals 100. Okay. Somehow we always have a way of knowing what's better for you than you do. Okay. I tell my kids that all the time. And then if QD equals 200, I plug in 200 on the left where QD would have been, set it equal to the same right-hand side, 500 minus 50p. Again, add 50p to both sides. Or in my case, I was always taught you hop it over and change the sign. Like a rabbit, he hops over, but he changes his sign, so he becomes 50p. This guy hops over, but he becomes negative, so that becomes 300. And then p equals 6. So however you were taught your algebra, right? I know there's a slew of fabulous, fantastic middle school grade math teachers out there that taught you this. And I hope you were paying attention, because now you need it. All right. So anyways, p equals 6 and quantity equals 300. Cool, we're cruising. Now I'm going to leave it up to you guys. Again, the math skills. I'm just here to teach the econ. You need to teach yourself the math skills, not teach yourself. You just need to brush up, because I know you were taught this. Okay. You need to figure out what it is when price equals 4, price equals 2, and price equals 0. And you can do that. See, QD equals 300, QD equals 400, QD equals 500. Oh, wait, we already did that one because that's the intercept. When QD equals 500, we know P equals 0. We solved that back here, didn't we? Oh, look, it's right there. Yay. Okay, so you got to go and figure out 300 and 400. Okay, when you're done, hint, hint, your graph is going to look like this. All right, not with the TRs yet, but your graph will have all these different steps, A, B, C, D, E, and F. And each point represents a combination of price and quantity. So at point A, my price equals 10, my quantity is 0. At point B, my price is 8, and go down, my quantity is 100. And at point C, if I charge $6, I could sell 200 hamburgers. And at D, if my price were 4, I could sell 300. This should sound a lot like that demand schedule that we saw in a previous lecture. Hint, hint. All I did was take that same demand schedule and write out an equation. It's the same exact numbers. That is so cool. Okay, because now we have more information. With an equation, we can account for, hey, what about $7? Hey, what about $5.50? Hey, what about $2.37? With an equation, all we do is put in that price and we can calculate the Q. With the demand schedule, you don't have all of that information. You only have the few rows that I gave you. You're limited. So a demand schedule is like, kindergarten. An equation, now you have full information. Now you're a grown-up. You have all the prices and all the quantities right there at your fingertips in that equation. That's why it's superior. Okay? So now we're grown up. You guys are awesome. You're in college. Welcome to the big leagues. We brought you up from the minors now. Okay? All right. But now what we're interested in, ta-da, you now have the same demand curve that you had before in a previous lecture when we were doing hamburgers at Disney World. Should look familiar. Okay. Now what we want to do is at each one of the points, at point A, at point B, at point C, at point D, at point E, we want to find what would be the total revenues that I could collect with that combination of P and Q. So I want to calculate total revenues at each point. And going back, do I have the equation? Where was it? Total revenues is, oh, that was from a different lecture. Oh, here we go. Total right here. I knew I had it. Total revenues is equal to P times Q. Let me highlight it. Oh, look, it's right there. There it is. See, I told you it's there. Total revenue is equal to P times Q. So all I do to find here in my wonderful handwriting here, to find the total revenues at point A, I take what is my price at point A times what would be my quantity at point A. And that will give me how much total revenues I'll collect at the end of the day from point A. So at point A, we notice over here that my price is 10, so I'm going to substitute that in, but my quantity is 0. Nobody would buy a hamburger at $10, so 10 times 0, obviously 0. But now at point B is $8. If I were to charge $8 for my hamburgers, I could charge 100. See where that is on the graph here? B corresponds to price of 8, quantity of 100. So I plug that in. Total revenues at point B is going to equal the price of B times the quantity of B. And that's going to equal 8 times 100. And my total revenues for point B is going to be $800. And then you keep going, ... I'm not going to do all of these for you. I recommend that you do all of them. Hint, the answers are in the previous lecture. Okay? All right. But anyway, so you're going to calculate total revenues at C, total revenues at D, total revenues at E. And here, I cheated, and I gave you total revenues at F. So total revenues down here at point F is going to equal to my price of 0 times my quantity of 500, and that's also going to be 0. So now I have a whole bunch of total revenues. I have total revenue for A, total revenue for B, total revenue for C, D, E, F, okay? I want to plot those and see what the total revenue curve looks like. So that's the next. Now let's summarize. Let's take all those calculations that I did, and I'm just going to throw them into a table, okay? So in my table, I put all of my P's, the corresponding Q's, and then the total revenues. This table should look a heck of a lot like the table in the last lecture. If you've been following along loyally, and I appreciate those of you that are, you remember this. So all I did these math, and then I'm taking those TRs and I'm typing them in with the right Q's, and you'll get this. Okay, so now that I have the table, now I'm ready to stack my two graphs on top of each other. Graph 1 is the demand function, so I'm going to plot Q and P. On graph 2, which will be underneath the demand function, I'm going to have Q on the horizontal and total revenues on the vertical. In both cases, my Q is going to be the horizontal axis. All right, so what does this look like, you ask? Ta-da! And I do apologize, it's big. Let me make it a little bit smaller. There we go. So now you can see this. I'm going to go just a little tad bigger. Okay, bear with me 1 second. I need a sip. All right, so I've plotted this demand curve. I sketched it just like I did. I have already done this in a couple of lectures now, the same demand curve. So I got my intercept up here when Q is 0, P is 10. Down here when price is 0, Q is 500. Connect the dots, straight line. The blue line is my demand curve. To get this total revenues function, a lot like I did in the previous lecture, because you remember the previous lecture, go back and watch it if you haven't already, right? When we're stacking graphs, we always put the same horizontal, okay? And in fact, they should be identical. So that this 100 matches up with this 100, this 200 on top matches up with the 200 below it, 300 above, below, 400 above, below. Yeah, that says 400, 500, 500. All right, so now I've got them stacked on top of each other so that the two horizontal axes are identical. My vertical axes will be different. On the top graph, it's going to be the prices. This is the demand curve. We've done this so many times, and I'm not going to do it again. But instead, let's jump down here to this total revenue function. And what I did was I plotted, I always set my axes first. So I did 500, 1,000, 1,500, equal intervals, 500. Then I added in the values that I knew from the table, 800 and 1,200. So I plotted those in red, 800, 1,200. And then you just graph these two columns, the one in the middle, one on the right. When quantity is 100, total revenue is 8. Okay, well, let's go over to quantity of 100 and go up to 8 and put a green dot there. And there you go. And then go back to my table. When the quantity is 200, my total revenue is 1,200, right? So at a quantity of 200, I go up to 1,200 and so on. And you keep plotting these and your total revenue function will look like that. And there you go. Now you have the stacked graphs. The cool thing is, a lot like the previous lecture, hint, hint, go back and watch the previous lecture. You can add in what you know about elasticity. And what you know is that, let me see if I can do it. Insert, shape, let me do a straight line. On this side of the graph, and I'm going to make that a little bit bigger. I'm going to make it nice and red, and I'm going to make it nice and big. There you go. Okay, so on this side, and even let me go better one step further, just because I like shapes. Shapes are cool. On this side and this side, oops, copy this guy, paste him up here. Can I? Where did he paste? Sometimes he just flies all over the place. There he is. And again, I'm going to make, oops, I'm going to make him red. And again, I'm going to make him thick. There we go. Same thing here. Let's make it a big red arrow. And so, there we go. Those two red arrows in that region from 0 to 200 quantity, that's going to be the elastic portion. Okay. And then in the middle, and again, this relates back to elasticity along a linear demand curve. Go back to that lecture if you're not knowing where I'm grabbing these from. Okay. I'm going to do insert shape. I'm going to do my straight line. So over to here. And again, making it red, making it larger, right? Maybe moving this over just a little. There we go. Oh, that looks a little better. Okay, so then this section in between where it's flat, the top of the TR curve, you see it? And then insert, oh, actually, let me copy him. I can just copy that guy, paste him up here somewhere. Where did he go? He went up here, put him right there. And again, making him, if I edit him, I'm going to make him green in this case. Let's go green. I like green. And let's make him large enough that you guys can see what I'm talking about. There we go. That green arrow, right? And same thing here. I'm going to make him green, green, and I'm going to make it a little bit heavier so you can really see him. There we go. So the two green arrows that represent the flat portion, the top of the TR, that's the unitary elastic portion. And then the third part over to the far right, and I'm going to denote that with a pink arrow or something over here. Let me do a yellow arrow maybe. Let me do, what color do I want? No, let me do something that stands out. Let me do a purple. I like purple. Purple's a good color. And then make him super big. There we go. And then I'm going to copy that guy. And I'm going to paste him down here. Yeah, but he posts up there first. There we go. So this guy on this side, that's the inelastic portion. Okay. So now you can see the three regions as they relate to elasticity. So this upward sloping part, elastic, flat part, unitary, falling part, inelastic. Okay. And that relates to the elasticity along a demand curve. Go back and watch that lecture if you don't remember that. Okay. So there you go. Now you've got the different regions you can show on both the demand curve and the total revenue, because the regions match up, right? They match up perfectly. Okay. And so there you can see, and that is what the firm is going to use for their decision-making process. So there you go. This is what one of the questions on the homework. So those of you that have actually taken the time and watched this video all the way through now know how to get optimal points on that question. Is it question number 3, I think, on the homework assignment, where I throw you the curveball with the equation? Now you can do it because you have all the tools. It might need a little bit of dusting off of the algebra skills, but I have confidence. You guys are smart. You guys are super smart. You're in college. You can do this, okay? Just takes practice, that's all. If you have any questions, reach out with the caution. I think I've mentioned it before. I am the biggest sports fan in the world. And if any of you want to challenge me on that, I'm happy to go at you. We can talk about the rules of curling and biathlon, which I know completely inside and out, and how the diving is, or how the scores in synchronized diving are calculated. So if once you're ready to argue those points with me, please let me know that you're a bigger sports fan than me. I would love to meet that person that is in fact a bigger sports fan than me. I haven't yet. But anyways, that being said, I'm the biggest sports fan in the world. So guess where I will be on Sunday? Glued to my TV. Even though my Pittsburgh Steelers are no longer in it, I will be cheering for my boy, Tom Brady. We went to college together. Yeah, we're good friends. No, I actually saw him walking across campus. He probably wouldn't recognize me. I actually worked with him on a couple of events. So he might look at me, know I look familiar, but he wouldn't know my name. But anyways, he's a good guy, let me tell you, because he's a Michigan Wolverine like me. So I'm cheering for the Buccaneers, obviously. My son is cheering for the Chiefs and Mahomes. It should be a good Super Bowl, but don't try and email me during the Super Bowl. You're not going to get a response. It's silly on you for waiting until Super Bowl Sunday to email the biggest sports fan in the world and ask them a question about economics. It's not going to happen. So please email me on Saturday. Please email me Sunday morning before noon, because the pregame obviously starts several hours before the kickoff, and that's where I'll be. And enjoy those commercials. It should be an interesting set of commercials this year without the big boys, without Budweiser, Coke, and Pepsi. I hope the smaller companies now have a chance to show what they can do with fantastic commercials. So it still should be entertaining. And let's talk about it later. Maybe we'll have a discussion thread on your favorite commercial. Maybe there'll be some extra credit in there. So thank you guys for listening. Thank you guys for watching. I hope this has helped. Reach out, but reach out early. All right. And get it done by Sunday night. All right, guys, good luck. And I'm with you. I'm your coach. Go team, go.